All right, I want to talk about section 8.10 real quick, Polygon Classification. So recall that a polygon is just a closed shape with straight lines. And it needs to have these requirements to be a polygon. I think they'll be asking you about this later and giving you some things to see. Is this a polygon? Is this not? So you'll need to refer back to this definition. But we have a bunch of different names for polygons. For example, we can say if we were to sort them by their sides. Now I can't have a one-sided polygon. It's impossible because I can't have a closed shape with one side. And I can't have a two-sided polygon either because if I did two sides, it would kind of look like this and it would be open, right? So the minimum number of sides I can have on a polygon is 3 sides. And the name of this shape is a triangle. And we know that these look like this. And something that happens that's interesting is we can also say that the total degrees in all of the angles will also be always the same. For example, I can write this as the sum of interior angles. Oops. And on a triangle, we know this to be 180 degrees. If I add up all 3 of these, I get 180 degrees. Now, that's only true for triangles. If I go to the next sided shape, for example, I can go to 4 sides. This shape we would typically call a quadrilateral. They look like this in their picture. 4 shapes, or 4 sides, and they don't have to be a square or a rectangle. They can be bent. It doesn't matter, but they need to have 4 sides. And in this case, the sum of interior angles is going to be equal to 360 degrees. Next, we can have 5 sides, and I actually should have written sides / angles, because there's the same number of sides as angles. And a 5-sided shape we call a pentagon. Again, this goes back to Greek roots. Penta means 5. And I'm going to be doing my best to draw these pictures, but I can't guarantee that they're going to be perfect. My pentagon is flat. Kind of like that. 5 sides. And the sum of our interior angles is 540 degrees. Our 6-sided shape is called a hexagon. Hexagon is our... It's not our stop sign. I can't remember what a hexagon is. But it looks like this. And our total angle is 720 degrees. 7 sides. It's a heptagon. These are weird looking. One, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6. Oh no. Well, it's supposed to have 7. Pretend it went like this instead. They're difficult to draw. You guys will be better, I'm sure. And we have 900 degrees as our total. Our 8-sided octagons. Our stop signs. And our total sum of our angles here is 1,080. Oops, I was off the page. Sorry about that. Number 9. We call these nonagons. Do my best to draw it. Okay. Terrible, but the idea holds. 1,260. And lastly, our 10-sided shapes. Now, of course, you can go up as high as you want, but typically we only count up to 10. We say they're called decagons. And I'll do my best, but one, two, three, four, five, six. Well, and our total sum is 1,440. And you might notice that there's a little bit of a pattern in how these numbers here go and how they grow. And it's quite simply that after this first one, every time, all we do is we add 180 degrees. And we can come up with a pretty easily rule to see how this works. We could say, how many degrees are in a blank-sided shape? And our rule here is this. So if I think of my triangle as being number 1, I can say that triangles equal 180 degrees. So what I would want to do is if I write the number of sides, and I can write that as x equals number of sides, I could write x minus 2 equals it would be x minus 2 times 180. And this is going to give me the total angle that I need for any of these. So if I'm curious how many total interior angles, what the degree is going to be, all I can do is this. So for example, I can take my octagon, 8 minus 2 is 6, and 6 times 180, hopefully this is going to work, 6 times 180 is 1,080. That is correct, and there I go. You're going to be answering some questions based on a lot of these and things that we've talked about. If you get stuck or have any questions, ask me, ask a friend, look it up on Google, or any other way that you can think of. Good luck.